And we are on to our final video for the week. We're looking at section 8.4, and that will be talking about parallel lines and proportional parts. Okay, so here we have these things that are called triangles, as we know. And I like to look at these problems and call them bugle problems. If you don't know what bugle problems are, think back to the chip called bugles, right? And what you tend to do with bugles is you take them, put them on your fingers, look kind of like a witch, right? So what I call these bugle problems is it looks like two bugles inserted inside one another. Okay, so I learned that in high school. I've never lost it, so I'm going to call these bugle problems for the remainder of our life together, if you will. So there's a nice, wonderful theorem that comes from these problems. Okay, so first off, here's a fact. In any triangle, a line parallel to one side of the triangle separates the other two sides proportionally. So this line that cuts this triangle in half, so these two are parallel right here, should be marked like this. Okay, it makes these sides over here be proportional, and it actually does way more than that. So we're going to use that theorem nicely, right? If x, y, and rs are parallel, then rx, this piece right here, over this piece is equal to this piece over that piece. That's the theorem that we're going to use. But what it actually does, the reason this is true, why, is that what it does is it creates two similar triangles. Take this tiny little triangle, looks like this. Can't draw very well today. There's the tiny one, xty, and here's the large one, okay, trs. If you look, I kind of deconstructed those. Those two triangles are similar, okay? And so you could actually use the fact that ty, small piece, over the big piece, ts, is equal to tx over tr. You could use that as well. So I'll put that one here. Or small over big equals small over big. Okay, that would work as well. There's all kinds of wonderful proportions that come out of this because those two triangles just happen to end up being similar. Okay, so let's go ahead and use this fact. We will primarily rely on this one, but if you ever need to, don't forget about this guy. Okay, so looking at number 1 here, it says find x. Now we do have parallel lines. Remember, it cuts these in half. It doesn't matter what order you set these up in, though. You can go 20 over x or x over 20. I'm going to go 20 over x because it feels more comfortable to me. So we have 20 over x equals, okay? Now, if I chose 20 on top over here, you really need to go 18 on top over here. It doesn't matter what order you go in, but once you pick one, you have to stick to it. So if we have 20 over x, you certainly need to go 18 over 9. Okay, again, to solve this, you just cross multiply. You would get 180 equals 18x. Divide, and you would get x is equal to 10. Easy peasy. Okay. On number 2, again, these two parallel lines cut these sides proportionally. So you can go 18 over 6. Hope you can see this green okay. Equals x plus 22 over x plus 2. Go ahead and pause me and cross multiply and see if you can solve for x. Okay, let's continue. Cross multiply, and you would get 18x plus 36 equals 6x plus, what is that, 120, 132? Right down. 132. Subtract the 6x over, you get 12x. Subtract the 36 over, what is it, 96? 132 minus 36 is indeed 96. Divide by 12. Don't want to mess this up. 8. X is equal to 8. Okay? Not terribly difficult, is it? Now at this point, you've seen everything that I'm going to go over. You have all the material that you would possibly need. Look at that. Only 4 minutes in. Isn't that wonderful? I'm going to go through some more practice problems just to give you an idea what your homework is going to look like or what your test will look like. But if you feel like you have enough information to do the problems, go ahead and stop here. Okay? I'm going to continue, though. So, number 1, okay, this one's very much like the problems we just did, but it's already set up, right? These parallel lines cut it proportionally, so we can go 24 over x or x over 24, pick your favorite. Let's go x over 24, because why not? Now, if we chose x over 24, we need to make sure that we match on this side. So it's going to be 10 over 30. Cross multiply, you get 30x equals 240. Divide by 30, and you get x equals 8. Easy. Okay, make sure you're asking yourself on the quiz, hey, is that what the question actually asked for? Did it just ask for x? Did it ask for the perimeter? You can ask all kinds of questions, okay? Same process on number 2 here. We would go 5 over 10 equals x over 7. Cross multiply, and you get 35 equals 10x. Divide, and you get x equals 3.5. And that's all there is to it. Okay? So when they're set up nice like this, there's nothing crazy going on. Now let's go find one that's not quite so nice. And this is kind of what I want you to see, because this is very similar to a quiz question. So on number 3 here, you see we have this side and this side, but unlike the other questions, where on all of them we had all 4 parts, we don't actually have all 4 parts here. And so there's a couple of ways to do this. To use that first theorem where we go this part over that part equals this part over that part, we're actually only missing one thing. What we're missing is this piece of information right here. But it's not terribly difficult to find, so let's continue doing it that way and just try to find it using this. Okay? So if the whole thing's 24 and this piece is 8, what is this piece right here, this KL? Go ahead and answer that question if you don't know. Okay, to find that, all you have to do is take 24 minus 8, and that will give you 16. And now you actually have what KL is, and everything's all good from there. Now, we can set up our proportion, and we would go x plus 5 over 6x plus 2 equals, over here we'd have 8 over 16. Cross multiply. I'm trying to make room here. You'd have 16x plus 80 equals 48x plus 16. Subtract the 16, and you would get 32x. Subtract the 16 this way, and you would get, what is that, 64? And you just get, over here, x is equal to 2. Okay? Definitely a higher difficulty question, but not completely unsolvable. And I only want to do one more problem, and I want to do this number 4 here. So now we're actually missing all kinds of information. We have the 13 and we have the 8, but we have nothing over here except for the fact that this is 42. So you actually have a few options, and there's not really a wrong one. What I'm going to do is I'm going to call RQ x, right? We don't know what that is. Actually, let's scratch that. We're looking for MR. Let's call MR x. That way when we find x, we're done, instead of trying to figure out what else it is. Now, if MR is x, we need to label RQ as something as well. But if the whole thing is 42 and this piece is x, then RQ is simply 42, let's put a little arrow here, 42 minus x. Just like over here, we had 24 for the whole thing. If this is 8, then to find this piece right here, we took 24 minus that 8 and got 16. Okay, the same thing works over here. So now again, quite simple, we have a proportion. 42 minus x over x equals 8 over 13. Go ahead and solve this. You get 8x equals 13 times 42, whatever that is, 546 minus 13x. Let's add 13x and divide. Maybe a nice number, maybe not. It sure is, 26. Okay? And that process should lead you through all the kinds of examples you'll see in the homework and on the quiz. Hopefully you do well. If you have any questions, feel free to let me know. But otherwise, have a wonderful day.